Welcome to the new series about the hybrid and full electric boats. This is a new series of courses and books. The book will be available in December, and the new course about the hybrid and solar boats will be available in January 2024. This video is only the introduction. In this video, I am going to explain the content of the future courses and the future charts and the future small videos, tips about how to create, how to design, how to convert your boat. Yes, this is the idea. The idea is that I want to explain in a simple way how to convert the actual boat that you have in a solar boat or in a hybrid boat. It's simple, it's not complicated. I am going to explain in my terms, in simple terms. I am going to explain the process to do the calculations for the new electric motor, the process for the calculation of the solar panel array, the process to calculate the battery bank, the process to calculate the breakers, the capacity of the breakers in the AC panel, in the DC panel. Step by step, it's simple. Exactly like the method that I use in my classes, in my courses. Convert a boat is too simple. You need to take in consideration that the boat is divided in the propulsion system and in the house. You can convert only the house, or you can convert only the propulsion system, or you can convert both of them. Depend what is your preference, depend what is your necessity, depend on what you want to use in the future. Okay, I am going to talk quickly about the propulsion system. I did this project, this prototype, a couple of months ago, and this is basically a short explanation about how can you convert a gasoline or diesel boat into a hybrid or full electric. I replaced my gasoline or diesel engine for this motor. This motor is basically this motor, the 10.0 quite torque. 10.0, according with the calculus, is good to replace a small gasoline engine 4 cylinders or a small diesel engine Perkins or Yanmar. With this electric motor, AC motor, you can produce the same or higher torque than the original gas or diesel engine. This is the great idea. And what is the process? I have a group of batteries. I have this group of batteries, lithium batteries, 24 volts each one. Of course, the capacity in amps is too small. This is only for learning purposes. In the class, I am going to explain how to calculate the proper battery bank, the capacity in amps, according with the length of the boat and the weight of the boat. This is for learning purposes. I connect those two batteries in series to provide 48 volts. Because the system required 48 volts. I put an interrupter in each line, in the positive line, in the negative line. In the negative, I install an additional shunt because I want to install an additional ammeter. This is why I install the shunt. And here in the positive line, I install a fuse, a heavy fuse, 250 amps. And here I have the inverter. The inverter converts DC 48 volts into 3 phases AC. With those 3 phases, I feed the motor, 3-phase motor. I install here, this is part of the system, that thermal relay, and the relay is activated with the ignition switch. As soon as I activate the ignition switch, the relay closes the contacts, and the current passes from this point into this point. And now I am ready. I have the display. Of course, the consumption in this moment is 0. I have a 0.2 amps, and in this one I have the voltage 52.39, and this is the amps. And I am going to start to rotate here. As you can see here, in this moment the motor is running at 1200 RPM. The consumption is only 0.34 kilowatts, and and the consumption in amps is 6.4 amps. It's practically nothing. Of course, it's because we don't have load in this moment. The boat is running without load. In the class, I am going to explain the process to simulate load. Okay, this is the prototype, and the propulsion system is ready. I can turn neutral or reverse. Okay, this is the propulsion system. The propulsion system is not complicated. The most difficult part is the design to use, for example, if you want to use the old transmission. You want to replace only the engine and use the transmission. I am going to explain the process to design the flange to engage the new electric motor with the old transmissions. And also, I'm going to explain other technique to install a pulley in the shaft, and with that pulley you move the raw water pump to keep cooled the transmission, the actual transmission. This is part of the course, and we are going to talk later about those processes. All of the internal process will be explained in future videos. Now we are going to talk about the house. What happened with the house? And this is the prototype that I create for the house. Once again, in the house, I am going to install 2 batteries of 48 volts in parallel. In other words, I will have 2 group of batteries. One group of batteries for the house, 48 volts, and other group of batteries for the propulsion system, 48 volts. And both of them will be charged with the solar panel systems, with the solar panel that we have on top, those solar panels, and also with the Victron system. In the Victron system, is an intelligent system. I am going to integrate the shore power, the generator, with an automatic transfer switch. With the automatic transfer switch, I am going to connect the shore power system here and the generator entering here in the bottom. And after that, we are going to feed the inverter charger, the smart inverter charger, this one. Those loads, shore power and generator, will be the input of the inverter. And of course, the output of the inverter will feed the AC panel, the new AC panel that we are going to install in that prototype. The DC for the input of the inverter is coming from this intelligent system, the link chunks and the link distributor. Both of them together, basically, they are 2 bus bars, intelligent bus bar, negative bus bar, and positive bus bar. Of course, they are connected, the positive bus bar, with a mega fuses, later I'm going to explain, and a big fuse here to connect the positive. Positive here coming from the positive of the battery bank, and negative here coming from the negative of the battery bank. And those fuses, intelligent fuses, the links, the shunt and the links distributor will be working together with the MPPT control system. The MPPT control system receives the power from the solar panels and send the power, positive and negative, here into the negative and positive of this group of bus bars. And from here, a new positive and negative, new negative here and new positive here, will be entering here into the inverter charger. We are going to do the explanation, the calculus about this step by step, slowly, in my way. After the MPPT, we are going to connect the Servo GX. The Servo GX is the brain of the system. The Servo GX integrate the link distributor, the link shunt, and the inverter charger together. This is the brain of the system, the Servo GX. All of those elements will be connected with a special display, and this is the display that we are going to connect here with the rest of the Victron system. Of course, we are going to use a lot of positive bus bar and negative bus bar, and this one will be the switch to isolate the solar panel array with the links distributor. Because the system is 48, we are going to install one DC to DC converter. The idea of the DC to DC converter is reduced from 28 volts into 12 volts because I want to install this 12 volts DC panel to supply power for the house, because the actual house of the boat is in 12 volts. The majority of the boats, small and medium boats, are in 12 volts. We can do the same if the boat is 24. We install the DC to DC converter passing from 48 volts into 24. The process is exactly the same. And after that, we are going to connect different loads in the AC panel, in the DC panel, and we are going to check the consumption in amps and the consumption in watts, the power. How is the process of integration in this particular system? Why the system is intelligent? Let me explain. We are going to install, if you see in this configuration, the output of the inverter charger, this is the output, hot, neutral, and ground, will provide power for the AC panel. And the AC panel provide the power for the rest of the boat. In other words, the power, the electrical power in my boat will be coming always from the inverter charger. And the inverter charger receive power from the battery bank, and the battery bank will be charged from the solar system or from the shore power or generator if the boat is connected to shore power, or if the generator is running. Those elements activate the small charger located inside of the inverter charger, and with the battery charger you charge the battery bank. This is the idea. But if I am using my boat in the middle of the ocean, what is the idea? The capacity of my battery bank, the charge of the battery bank depends on the solar system. But in the moment that the level of charge in my battery bank decrease 20%, automatically the links distributor, the Victron system, send the signal to the generator start and provide power to recharge the battery bank until 96-98%. Immediately the battery bank receive that power, turn off the generator, and you continue using your boat. Once again, when the level of charge in the battery bank decrease 20%, the generator start again and recharge the system. This is why the system is called hybrid, because depend in some moments from that generator. The generator will be a small generator, and a generator that the consumption is nothing, because it's a small generator only to provide power to the inverter charger, and the charger charge the battery bank. This is the idea, and I am going to explain the process to do that connection, the connection in between the intelligent system and the generator. How will be the signal, and how will be connected the signal. And I am going to explain two methods to do that. One method to connect that signal in a traditional analog generator, and the method to connect that signal with a new digital generators. The new generators, they are coming with the option to start remotely from the intelligent system. But the old generators, they don't have that option, but you can create that option. I'm going to explain with a couple of time delay relays. We are going to do that conversion, and it's simple. I have an old generator diesel, a small generator diesel, and I am going to do the diagram easily and the connection easily to understand in a simple way, in a simple diagram, how to do that connection. This is the project, guys. I hope you enjoy this project. This project is possible basically because the support of Broward College. Broward College and Marine Technical Training with Mr. Lopez, we are creating this group of videos, this series about the solar and hybrid boats. I hope you enjoy this wonderful work, but I need your support. The only way to continue is if you subscribe in my YouTube channel. It's free. Please subscribe in the YouTube channel, and if I accept donations, any thanks in my channel, the YouTube is nice for me. $1, $2, $5. This is the only way to continue. If I don't receive support, probably in 2 months, 3 months, I finish. The only way to continue is with your support and also with donations. I receive donations, electrical donations. I need an air conditioning equipment for this project, air conditioning equipment AC and other air conditioning equipment DC. I accept donations. The course will be available in January of 2024. I hope you enjoy this series. I hope you enjoy this work. If you have questions, you can write an email to info@mrlopezclasses.com, or you can text a WhatsApp message to my phone number 954-793-0029. Thank you.